Hello and welcome to our differential equation class. In this class we are essentially going to talk about ordinary differential equation, but in the first chapter we will see what is ordinary differential equation essentially. Okay, so in this chapter basically we will discuss a motivation why we want to study differential equations, and then we will see the classification. Every one of you must have heard about this famous quote, change is the only constant. So everything around us keeps on changing, right, with respect to some other thing. All the laws in our universe are written in terms of mathematics, in the language of mathematics. Any interesting phenomena you can talk about will be involving some change, some related change. And in our Kelvin class, we learned the meaning of, let's change the background, the meaning of derivative. dy over dx means change in y with respect to x. Like how the y is behaving, how the function y is changing if we are changing x, right? So this was the meaning of dy over dx, the derivative. So previously we learned about the equations like the algebraic equation x square plus y square equal to 5 equal to plus 5 equal to 0. So these are algebraic equation. Now if any equation which involves the derivative, we will call it a differential equation. So very simple definition. Of differential equation containing the derivatives are called differential equations. For example, d square y over dx square, the second derivative, plus 100xy equal to 5. This involves a derivative, so this is a differential equation. Now if we solve the algebraic equation, we always get a number like x equal to 5, y equal to 100 or anything, right? The solution of differential equation will always be a function. So solving this differential equation means we get a function y in terms of x. So we will say yx is a solution if we substitute the double derivative of y, if we substitute y in this differential equation, it satisfies the equation. In given equation, in given differential equation, it satisfies the equation. then we will say, okay, yx is a solution for this equation. Okay, now we know if a function is solution or not. The things you need to remember here is a solution of, by DE we will denote differential equation, is always a function. It can be a constant function, but it's always a function in terms of independent variable. Here the independent variable is x, so y will be in terms of x. Okay. Now, how we use this differential equation, why these differential equations are important. Now, every phenomena can be described in terms of differential equation. So why engineers, mathematicians, every science professional, every engineer professional is interested in learning differential equation is because we have some real world problems, we do some formulation and we make a mathematical model. We analyze this mathematical model using the mathematical tools, whatever results we have, and we derive some mathematical results. Using these results, we can predict about that real world problem, what is going to happen, how we can control things and everything. Now suppose if we can solve all the differential equation, we have a real world problem, we make a mathematical model, and if we can solve all the differential equations, that will be great, right? We can predict everything. We can tell, okay, this is going to happen. If we want to avoid something, we can avoid this way. If we want, we are prepared for everything that is going to happen. That will be great, right? So the natural question we ask is it possible to solve all differential equations? Unfortunately, the answer is no. There are very simple looking differential equations which are not possible to solve. In this course, we are going to discuss some forms of differential equations which we can solve easily. Let me give you a very simple example. Y prime. Okay, so let's fix some notations. So dy over dx, which is derivative of y, can also be denoted by y prime. Some authors also denoted y and a dot over it. One dot means first derivative, two dots means second derivative, and so on. So y prime absolute value plus 1 equal to 0. This differential equation is not solvable because this value is always going to be positive. And if you add 1 to it, it's always going to be greater than 1. It will never be equal to 0. So this differential equation is not solvable. So what we are going to do in this course is we are going to discuss differential equations which are solvable. Some types of differential equation, not all of them obviously. Okay. So our first classification is, we will classify the differential equation as ordinary differential equation and partial differential equation. Because in this course we are going to discuss only ordinary differential equation. So first we should know what ordinary differential equation mean. So if a differential equation have only one independent variable, then we will say this is ordinary differential equation. If it have more than one independent variable, it's partial differential equation. Let me give you some examples. D square x over dt square plus 5t equal to 100. D square x over dt square plus dx over, say, any other quantity L plus 5 equal to 100. In the first case, our independent variable is just t. So this is ordinary differential equation, which we also denote by ODE. In the second case, we have two independent variables, t and y. T and L. So this is partial differential equation. So this is how we classify ordinary differential equation and partial differential equation. In the coming lecture, we will discuss about order, degree, if an equation is linear, non-linear, homogeneous or not. And I'll see you in the next lecture. Bye-bye.